Welcome to a lesson with Dr. Powell. Let's take a look at what it means to solve a system of inequalities like this. What we're going to call a solution is simply a picture of all the coordinate pairs x, y in the xy plane that satisfy all three of these simultaneously, these inequalities for these xy pairs. For instance, um, for the top one, the point 2 comma 3 definitely would. 2 plus 3 is bigger than 1. So that would work. So how we do this is we think, first of all, we answer the question equal. So let's look at this first guy. Y plus x equals 1 is right in between the two ideas of greater than and less than. In fact, it's the boundary or the border. So all we have to decide is what, as we cross the line x plus y is equal to 1, x plus y equals 1, actually be like this. You can kind of think roughly of this as being of just plugging in a point or two. You plug in y is 0, and notice x must be 1. When x is 0, y must be 1. So we have a line like this. The question is, on which side do we actually have x plus y greater than 1? This side or this side? Well, it just takes one thing to check. Like down here, why don't we just check the origin, 0, 0. Check this in here. 0, 0, if you plug it in, you notice 0 greater than 1? No, 0 is less than 1. Therefore, we don't include over here. So we're just going to include the other side. Now, keep in mind, this is a greater than, not or equal to, so we're not going to include what's on this line. Now, to do that, we just make the line dotted. And this inequality itself is just everything shaded over here. We do the same thing for each one of these inequalities and then just see where the intersection is of the results. Notice that what solves this inequality is coordinate points in the plane. It's like a whole huge piece of the xy plane, everything over here, but not including this line. So the dotted line is analogous to what we have an open circle on the number line when we're trying to map out something like this, like an interval on the number line. And we just want something bigger than, but not equal to. Okay, let's look at the next one. We have y minus 2x is greater than or equal to negative 1. Again, we look at the scenario when it is this one where we have equal, because that's going to be the boundary. We're going to rearrange this to y is equal to 2x minus 1. Just think about that for a minute. That's the slope of 2x. Y-intercept of negative 1. So it looks like something like that. So we have a line like this. Which side should we shade? This side or that side? And notice this is greater than or equal to, so we'll actually be including this line so we don't have to dot it. So we're going to include it on which side. Now notice the origin is again on one of the sides. If it wasn't on the side, we'd have to pick a different point. In this case, for 0, 0 works, we could plug 0, 0 in. And notice that 0 is indeed greater than or equal to negative 1. So we should be shading over here. Now, let's just show that we can plug in other things. We could have plugged in, particularly we could have plugged in the point x is 0, y is 1 into here. And notice it still would have worked. X is 0 and y is 1. 1 is greater than or equal to negative 1. So that would have been just fine. Okay, so next we look at this one. We need to find out what the boundary of this inequality looks like between being less than or greater than, and it's when we have an equal. What is this? This looks like the equation of a circle with radius 4. And which side do we use? Well, let's try the origin, which is on the inside. Plug in 0, 0. Notice that it's true. 0 is less than or equal to 16. Therefore, we're just going to shade the inside here. Now, our next goal is to put all these together into one graph to see what the intersection is. So let's step through putting all these graphs on the same, in the same place. Okay. So let's see, 1, 2, 3, 4. Okay, so first of all, we have a circle and looks like this is less than or equal to. So we can draw a closed circle, and we know what we're looking for will be on the inside of the circle. How we shaded it here. Next, let's draw this line. Okay, 1, so 2, and it's not dotted since it's or equal to. Okay, next, let's do this one. This one is dotted. Okay, we're going to start thinking about the shading now. So this guy we shade up here. This guy we shade up here. And the circle we shade on the inside. Those put together lead us to believe that right here, this area, but not including that dotted line, but going all the way to these other boundaries, is a picture of the solutions of this inequality. So if we want to know what coordinate pairs x, y satisfy all three of these inequalities at the same time, we look at this picture and it tells us everything in there. Thanks for watching.